about this carbon, because carbon is special. Carbon, this line, it's a carbon. So carbon can make a simple compound like this that you already know. What's the name of this compound? With the carbon, methane, and 4 hydrogens. And you can have very complicated structure. So all of these are carbons. What other, so the carbon is the, so compound is organic, contains carbon. We call organic because long time ago, all these compounds were isolated from living things. So, but now we can synthesize all organic compounds. So what other elements you can find in organic compounds besides carbon? That's very common. Somebody said hydrogen, that's good. So carbon, hydrogen,
Oxygen.
Oxygen is important, nitrogen, and halogens, but both are important. Now, look, so we'll be looking at the periodic table. You already know how to read periodic table. I will be giving you periodic table for your quizzes exam. So look at the periodic table at carbon. There is a number 6 above symbol C for carbon. What's this 6 means? What's that?
6 proton.
6 proton. How we call this number? Atomic number. So carbon has 6 protons. Atomic number is 6. And what's this 12?
Mass number.
Mass. So what's this? How you will calculate the mass number? Number of proton plus neutrons. But when we look at the periodic table, we don't have 12. We have 12.011, not 12. So because carbon can exist as carbon 12 and carbon 13. So isotopes. So how we can define isotopes? What are isotopes?
What the average number of neutrons?
They have to have the same number of protons because they have to be the same element, carbon. But they will have a different number of neutrons. So their mass will be different. And this number 12.011, what you see, what's that?
The average weight.
Yes, that's right. So that's average, depending what's the percentage in nature of each isotope. Now, you already know this, how many bonds carbon will make? 4. And remember, you can have less, but never more. I can remove a hydrogen, still carbon. I can remove another one, still carbon. I can I can have negative charge, positive charge on carbon, but I cannot have never ever more than 4 bonds to carbon. So what kind of bond is this? What type of bonds you know? You learn in general chemistry.
Pi bonds and sigma bonds.
That's right, but that's true. But this one is covalent. Yes, but he's right. That's a sigma bond. That's good. That's a sigma bond. All single bonds are sigma bonds. So, but other types of bonds that you remember will be
Ionic.
and ionic. So this one for sure will be covalent. Why are you so sure? Why we know that this must be? Look at the periodic table. Actually, hydrogen in a periodic table is far away, but should be closer to carbon because difference in electronegativity is not big, it's less than 0.5. Why? So that's because in which, so looking at the periodic table, we have column and row. And in which column is carbon? What's the number of column? Number, here's 14, but actually should be 4. 4. So like 4. So the group number 4, what's this mean? If the group number is 4.
There's 4 valence electrons.
Very good. How many valence electrons? So the carbon has 4 valence electrons. So maximum possible electrons around carbon should be 8. All the second row elements no more than 8. So that's why can form 4 bonds, because can accept 4 more electrons around. So group number 4, 4 valence electrons and 4 bonds, because needed 4 more to obey octet rule, to have 8. So which atoms make bonds with itself and all other atoms? Carbon. Which atom can form long chain and rings? Carbon. That's why carbon is so special. Carbon, our bodies, organic compounds made from carbon. DNA long chain made from carbon. Everything around us here, organic compounds. That's why organic chemistry is so important in medicine, in pharmacy, or other fields you will be studying, because of the carbon is so important. So when we look at the carbon, how many shells you will have? 2. On the first, what's the maximum number of electrons for hydrogen? 2. And in the second, maximum 8, because you can have 1 S with 2 and 2. How many? So you already know that S and P, what's that? Orbitals. So how you can define in your own words, what is orbital? In your own words, what's orbital in chemistry?
Is it like an energy state for electrons?
No, you can define like this, or it's area, the space with higher probability to find the electron. So the single orbital maximum number of electrons for single orbital will be 2. So that's hydrogen will have first row 1 and noble gas maximum 2. You already know this. We'll not be doing this. We're reviewing. We are reviewing your general chemistry, what will be needed in organic. What is the shape of s orbital first? S orbital shape is
Like a sphere.
very good. That's the area that's higher probability to find the electrons. And the p orbital shape is different. P orbital, so that's the electrons in p orbital are more far away from nucleus. So that's why this is lower energy, more stable, because the electrons are closer, tightly held. And here electrons are more far away, so will be less stable, higher energy. If they are in the same shell, of course, comparing S and P in the same shell. Because the higher the shell, electrons more far away. So the second row will have 2s and 3p orbitals. So actually in organic chemistry, we will be mostly only talking about S and P. We will not talk about the D and F orbitals, because we will mostly talk about elements that are in a first and second row. So which electrons are involved in chemical bonds?
Valence electrons.
That's good, yeah. So that's why the carbon will have how many valence electrons? 4. Nitrogen. Look at the periodic table. That's why we will always look at the periodic table, because everything is in periodic table. 5, 6, nitrogen 5, oxygen 6. So group number is a number of electrons that are involved in chemical reactions, so that's very important. Notice that this is not working, and I should always bring my cell phone with me. I don't have, so I don't know what the time is. Because it's not working. Is it? This is wrong, is it? Yeah.
It says like 10:55.
So what time is it?
9:20.
Okay. I should bring cell and look at the time. Okay, so I know that some of you already know this, but if you had general chemistry a long time ago, or if you don't remember, we have to know how many bonds both elements can have. So carbon, what number you should put here? 4. Why? Group number 4. So what's the number of bonds in neutral atom? Number of bonds? 4, because 4 needed to have 8. So what's this mean, lone pair?
Things are just by themselves.
It's mean by itself, very good. Or it's not bonding, not involved in bonding, by itself, very good. So the carbon will have those or not? No. So 0. Nitrogen. How many electrons are involved in chemical bonding for nitrogen, valence electrons? How many? 5. Number of bonds neutral nitrogen can have. Neutral nitrogen can have how many bonds? 3. Why? Because needed 3 to have an octet rule, to obey octet rule, to have 8. So 3, because together 4 and 4 is 8, 5 and 3 is 8. So how many lone pair electrons, non-bonding electrons nitrogen will have. So here's nitrogen, we say 3 bonds,
2.
2, very good. 2, because have to have 8 around. So will be 1 pair, 2 electrons. Oxygen. What's the number of valence electrons? 6. And number of bonds, neutral oxygen will have 6, so we needed 2 to have 8. And lone pair electrons, non-bonding.
2.
So oxygen, 2 bonds. So have to be 8 around. So 2. And halogens. How many? Group 7, so 7. And how many bonds? Neutral 1. And how many pairs? 3. So halogen, I will put X, can be any of this. Will 1 bond, so 3 pair or 6 electrons. And hydrogen will always make how many bonds? 1. No lone pair electrons, just 1 bond, always. No more than 1 bond for hydrogen. Carbon, you already said that you will have 4. So this you should remember. And these electrons are important for us. We will be looking at these electrons. So why atom bonds together? Why atom bonds to make compounds? Why they bound together, atoms? Why they make compounds? Because the charge, but even if they don't have a charge, they will bound if, why?
Their contact.
To complete, like boron, for example, to complete octet row, or if not in the second row, because they will be more stable. Everything in organic chemistry, the rule, whatever you are doing, think about stability. Everything react to be more stable, to have lower energy, to be more stable. So stability. Because after they bounce together, they will have a lower energy, they will be more stable. And we already said that this is example of what kind of bond? Ionic bond. So this bond is electrostatic attraction between positive, negative. And this is example of covalent. So here electrons are transfer from one atom to another atom. So one atom will be cation, another will be anion. They will have a charges, and here electrons are shared. So how we will know if you will have this bond or that bond? How you will know if electron will share or transfer electrons? We have to look at the periodic table. Periodic table will tell us if the elements are far away from each other, metal and non-metal, you know for sure that they will make what kind of bond? ionic bond. If they are both non-metals, they will make covalent bonds. So what is that? Ionic bonds. So metal will lose electron because after losing will be more stable. Everything is going to stability. And non-metal will accept this electron